Hello everyone. So today we will discuss about what is proximate analysis of a fuel. You may refer other video of mine wherein I have discussed what is fuel and how it is analyzed. There are two methods for the analysis of fuel, which are proximate and ultimate, and the comparison is done in that video. Now today this video would be more focused on what do you understand by proximate analysis. There are four major steps to do that. Like first, a solid fuel is given to you. The solid fuel, let's say a coal is given to you, so you need to use that coal sample in your industrial purpose or whatever purpose, and for that if you want to use it as a fuel, so by definition this compound should give enough energy on combustion, and that energy needs to be utilized further. So enough of the energy is required. We need that calorific value, the total amount of heat released, to be more, and for that there are certain quality checks which we need to do before using a particular sample as a fuel. So what are those? And the first step is nothing but proximate analysis. This gives you a general idea about the sample, like whether you can use that sample as a fuel or not. And for that, the first step is to find out how much moisture is present in the sample. The second will be focused on how much volatile matter it is going to produce on combustion. Third is like how much ash would be left after combustion. And then fourth is fixed carbon. Now as you know that there are certain parameters for a sample to be used as a fuel, right? So we need to know how much moisture is there, if it is less or more, and like that. So let us go ahead with the steps of proximate analysis. We are going to find them one by one. So let's see what is the first step. Obviously percentage moisture content. So we need to know how much moisture is present in the sample, and for that what you'll do is you'll first weigh the sample. Let's say the weight is W gram, and that you have to heat it around 100 degree. So for around 1 hour we are going to heat it, and when after heating we'll take the sample out, we have to again weigh it. So what are we doing is we are taking the weight of the sample before heating and after heating. And why have we selected this temperature? I guess you understand that the moisture is released at that temperature. So obviously this particular sample which you will take would be lesser in weight. The X gram would be lesser in weight because you have heated it, right? So how are you going to find out percentage moisture? You are going to find out by finding the loss in weight by sample weight. So what do you think? If you have taken W gram of the coal sample and if you have heated it for around 1 hour at 100 degree, so the moisture is released, right? And then whatever sample is left is free from moisture. So whatever is gone is moisture. So if I want to know how much moisture is present in this sample, I definitely have to subtract this. So there will be some loss in weight, and that loss in weight is proportional to the amount of moisture present. Divide by sample weight, because you have taken W gram, so you need to divide it by W gram in order to find out the percentage. That much sample contains this much moisture. That's why this is how you're going to calculate the moisture. So before going to this, let me revise what we are going to do in this proximate analysis. First we are going to use this crucible. Crucible is nothing but that silica ball which you are going to use, in which you are going to take your sample. So you have to put your coal sample inside this crucible. Now this is weighing balance or weighing scale, you can say. It is digital. You have to put your beaker or crucible here, and then here you can see the digits. Here you can see the weight of a particular product. So let's say the first step, you have to measure the weight of coal, how much coal you are going to use. So let's say I want to use 1 gram of coal. So I'll put that 1 gram of coal in the crucible. I'll see the weight, like how much gram of coal has been added. Around 1 gram we need to see. So we have to take that weight. Now once it is done, you have to use an oven. Around, like here we have to heat around 100 degrees, so a normal oven will do. Otherwise we have to go for muffle furnace if higher temperatures are required. So you have to put your crucible here in the oven and close the door, set the temperature and time, and that's it. So around 1 hour when you're going to heat it, we assume that whatever moisture is present in the fuel, that will be released. Now once you take the crucible out of this oven for 1 hour, what are you going to do is you're going to use this desiccator, which is like transparent, you can say the glass kind of container, wherein you can see at the bottom anhydrous calcium chloride is kept. So when it is anhydrous, I hope you remember, it is a dehydrating agent. It is hygroscopic, so it's going to absorb that moisture. So what happens is, if the crucible you're taking from the oven, and if you directly go to weight it, I mean if you directly put it on the weighing scale and you directly weigh it, don't you think that temperature is going to affect the weight? So what we want to do is we want to cool it down to the room temperature only, right? So let it come down to room temperature, and then we shall go ahead with the weighing. So what we do is, instead of directly going to the weighing scale, first we keep the crucible in the desiccator. Now in the desiccator it will look like this, right? So you'll put the sample, the crucible in which the sample is there, in the desiccator. And since the desiccator atmosphere is free from moisture, right, so here anhydrous calcium chloride is poured, so this moisture free environment is there. So now if you keep your crucible here, let it cool to room temperature, and then you weigh it. Otherwise what happens, when you are taking a hot crucible and you are directly weighing it, it may absorb moisture from the atmosphere again. So what we do is, before going directly to this step, first we put it in a desiccator, let it cool to the room temperature in a moisture free environment, because here inside moisture is not there, and now you weigh it. So now when you weigh it, I hope we can go back. So now what we have taken is, we have taken the coal sample in the crucible, right? Then you have put it in the oven and you have heated it, and then again you have to weigh the sample, but before weighing it you will let it cool in a desiccator in a moisture free environment. So you have weighed what is the amount of the sample left, and then to find out the moisture, you simply subtracted it, loss in weight, divide by sample weight into 100. Now what is the significance of doing it is, like, we need to know how much moisture is present, because if the moisture is in excess, I hope you understand that it lowers the calorific value. So greater the moisture, lesser will be the calorific value, and obviously the quality of fuel degrades. And similarly, it increases the transportation cost. In fact, the storage and handling cost also get increased, and then it is inconvenient to take that moistured fuel. So basically what we want to know is, the moisture content present in the fuel should be low, and for that we'll do this check. So let us go ahead with the next step. Now the first step is done, in which you have found how much moisture is present in the sample. Now there is one more feature which is known as volatile matter. I want to know about volatile matter also. Now what do we understand by volatile matter? Is nothing but which is volatile, which goes away from the chamber. So like when you allow the fuel to go for combustion, whatever gases comes out of it as a smoky flame or a gas, that is volatile matter. So normally like gases, methane, hydrogen, carbon monoxide, dioxide, etc., they come out of the chamber, and that is volatile matter. So I want to know about that volatile matter also. Like when I use that sample for combustion, how much gases is going to be released. So for that what you'll do is, you'll take the sample which is X gram. I guess you remember you started with W gram, then you heated it for around like 100 degree for around 1 hour, and the weight was decreased to X gram. Now I'm going to take the same sample, and now I go to next step. So here what I have to do is, I have to heat it for around 950 plus minus 20 degree, and for 5 to 7 minutes. Now you'll ask me that why this temperature is selected, how come you are directly going to 950 from 100. So I just want to tell that there are societies like American Society of Testing Material, ASTM. They have provided certain standards for everyone to follow. So if you follow those standards, and if you find out the answers, your answers are valid across the globe, and that is why we all follow those ASTM standards. So as per them, we need to heat it at this much degree, because at that temperature is the optimum temperature for all the gases to be removed, for all the volatile matter to be removed. So we want the assurance that the volatile matters are removed. So for that you have to heat it for 5 to 7 minutes, and then again you have to take the sample and weigh the sample. So the process remains same. You have to heat it and you have to weigh it, and you just have to find out now the volatile matter. So I hope now you understand that whatever is gone is volatile matter. So how much is gone? Obviously loss in weight. We started with x, we ended up at y. So x minus y gram would be the loss in weight, and that is nothing but volatile matter which is gone. Now you have to find out the percentage of volatile matter. How much percentage is there? So for percentage calculation you need to divide it by sample weight. Now what sample weight like you have taken? Are you going to write x here? No, you're not supposed to write x here, rather we have to write w. We started with w gram, I hope you remember. We have taken some w gram and we heated it to remove the moisture. So if you want to know the percentage of a particular like volatile matter in a sample, so you have to keep the sample weight same. Let's say 1 gram coal you have taken, so obviously you're going to find out how much moisture is present in that 1 gram, or how much volatile matter is present in that 1 gram. So this 1 grams remains same, right? So that is why you're going to use W here and multiply it with 100 to find out how much volatile matter is present. I guess this is simple. And now why are we going to do this? Because we need to know how much volatile matter is present, because we need to know that it should be low. So if we want to know that the quality of a particular fuel is very good, then the volatile matter has to be low, because this is the proportion which is burnt as a gas, or it may escape unburnt. So it's not going to contribute to your calorific value. Secondly, it larger the volatile matter content is, it will give long flame and high smoke. So that also is a problematic thing. And then you need to have larger combustion space. So this helps in designing the furnace also, because when you're using any furnace and it's not able to sustain the pressure because of the release of volatile matter, then it may explode. So before using a combustion chamber, we need to know how much tentative volatile matter will be released, so that your combustion chamber is sustainable enough to keep that pressure inside, right? So you need to know it should be low, so that no calculations regarding combustion chamber is required, no extra cost for maintenance and for making it is required. Then it is having a special significance in the solid portion also, like if you want to take coal gas, or if you want to make synthetic coal like coke. So if you are going to take high volatile coals, they do not cake well, and even low volatile coals also do not cake well. So it's like around mediator moderate range of volatile matter is required in order to get that hard and strong coke. Otherwise it becomes porous and soft. So that also is important in order to use the coal further for charcoal preparation or coke preparation. So I guess the second step is done. Now the third step is to find out percentage ash. What is ash? Is whatever left after combustion. So it's a waste which is left after combustion. Normally all inorganic substances are left after combustion. They are not fully combustible, like silica, alumina, lime, magnesia, iron, etc. And for that, again the procedure remains same. You have to take the sample, you have to heat it, and you have to take the sample back. So the heating is almost common. What varies is the temperature. And now here, if you remember, sample y gram, so we started with W, then we heated it for around 100 degree and we reached to x gram, then we heated it to 950 degree, we reached to y gram. And now we have taken that y gram sample and we are again heating it for approx 1 hour. Now this heating is done in a gradual manner. It's not like directly you have to reach to 750, but around 300, 400 you have to take a pause, and then you continuously increase the temperature slowly, and approx 1 hour you need to heat it consistently, so that everything is getting combusted, full combustion takes place, full release of gases or whatever is there has to react, and then you get a sample. Now if I want to calculate percentage ash, I hope this time you will not say that it is loss in weight, because loss in weight means whatever is gone. But here whatever is gone is not ash. In fact, whatever is left after combustion is ash. So what you have to write here is X. You have to write here is Z gram, right? And then you have to write divide by what? What are you going to write? What do you think? Sample weight, and the sample weight remains same. So you have to write W, not Y. So whatever is left is this sample, and whatever is the sample weight was same, and multiply by 100. So now why are you going to do this? Why do you want to know how much ash is present? So simple, because this is the compound which is useless and it's non-combustible, and when it is non-combustible it is not going to give you the calorific value, so it's not going to contribute to the calorific value, and that is why it is of no use. Secondly, what you can do is it like here, especially when I would like to say is ash is of two types, right? It is intrinsic ash and it is extrinsic ash. So with the help of this particular value, we can be able to decide that whether the ash is internal, like if it is present in the composition of fuel, or it is external, means it has come in the fuel due to external measures, like while traveling or while storage, some dust get attached to the fuel, and then that comes as a ash at the end. So if it is kind of extrinsic, you may take care of those parameters and you can reduce the amount of ash. So that is why we need to know whether it is like which type of and how, and so that we can target on calorific value of coal. Secondly, whenever it is high, the percentage is high, obviously it is going to increase the transportation, handling, storage cost. Additional cost would be there of ash disposal, because if so much ash is formed, you need to dispose it off. So where are you going to dispose it? That also is a problem, and it is going to consume some amount of cost. Similarly, it causes early wear of furnace walls. It get attached to those furnace walls which you use for combustion. It causes burning of apparatus. It causes trouble in burning because it forms clinker. So bigger size particles you may call as a clinker. So it forms clinker, and those clinker pose obstruction in the path of air. So the air supply is not proper, and the combustion becomes non-uniform or irregular. So that also is a problem when the combustion is not proper. So that is why we want to know how much ash should be there, and it should be low definitely. So this is how you find out. Now coming to the fourth step, you have calculated moisture, you have calculated volatile matter and ash. Now as per that standard, if you want to know the fixed carbon, you simply have to subtract these three from 100. So you have to plus them and you subtract it from 100, and you will get the tentative value of fixed carbon. And that is why we say that the proximate analysis does not give authentic results, because here a lot of manual intervention is there, and there are possibilities of error at every stage, because you are using like you are weighing it on weighing scale. There also it could be error. Then when you're heating it, if you don't heat it approximately at the same temperature and time, it may result in error. Then at the end you are also weighing it. So at every step the manual intervention is there. Also, if the moisture is not correctly calculated, it is going to be reflected in volatile matter, because same weight we carry on, right? And if it is wrong, it is going to be reflected in this. So overall this value which you calculate is obviously an erroneous value. So that is why we call that the proximate analysis is very empirical, and it gives you approximate results only. They are not more accurate. And for that you may go to ultimate analysis. Now what is the significance of this particular process? Why are we doing fixed carbon? Because we need to know that the percentage of carbon should be high. Higher the percentage of carbon, better is the quality of coal. So we need to know that. Secondly, percentage of fixed carbon also helps in designing the furnace, because that is which burns in the solid state. So that also helps us to design the furnace. Now coming to the revision slide of the proximate analysis, what we did was we weighed the coal sample in starting. Then the very first step is to find out percentage moisture. For that you have to heat it around 100 degree and just weigh it. Loss in weight will give you how much moisture is gone. Then you have to take the sample and you have to heat it at 950 plus minus 20 degree to find out what? Volatile matter, and then you'll get the sample. Again you will find out loss in weight. Whatever is the loss is due to the volatile matter gone. Now you take the sample, again heat it for 1 hour at 750 degree, and you will get the sample. Now this sample is nothing but product which is left after combustion, and that you call it as ash. So at the end we can find out the percentage of ash. So I hope you found it very easy to understand. Now let us cross check whether we really understood. So if a numerical is posed to you, that they say that a sample of coal was analyzed, you have used 1 gram of air dried coal. So the initial weight, I think W, you remember, is 1 gram. Now after heating for 105 degree, the dry coal residue weight is this. So they say that after one step the weight is this. Now they say that you have to again heat it for 950 degree and the residue weight is this. That means this is the second step weight, and then you again continue the same process, and the last residue weight was found to be 0.100 gram. So calculate the proximate analysis or do the proximate analysis. So how are you going to do? Obviously first you'll subtract these two to get moisture, then you subtract these two to get volatile, and you will use this as it is because that is what is ash which is formed. Now you have to apply the simple loss in weight by sample weight into 100. So this is your sample weight. I hope you can see from the question that it is 1 gram only. Right here it is written. So sample weight is 1 gram, and then this is the loss in weight which we have calculated. So find out the percentages, and at the end to find out the fixed carbon you need to add them all and subtract it from 100. So that's quite easy. Now coming to one more question just to cross check. The question says 2.5 gram of coal was placed, and the question could be big enough, they may explain the entire process in the question, but whatever is important is these values. You need to locate and decode these values. So now if I go in that manner which we started with W, so the sample weight W is 2.5 gram. Then we heat it for 100 degree, right? So that is moisture. So the weight is 2.015 gram. So x gram is this. Now you started with this x and you again heated it at 950 degree to remove the volatile matter. So what is the amount left? 1.528. So y would be 1.528. Now you have again heated it for 700 degree and around 1 hour, and whatever is left is ash. So what is left is 0.245, that is ash. So now if you want to find out the moisture, volatile, ash and carbon, I think you can apply the same logic and you can find out the answer. So both ways you can find out the answer. First you need to write your terms, then substitute the values, write the formula. Before writing the formula, don't jump onto the conclusion. And then at the end, whatever is asked in the question, you need to say that for the particular sample these are the values which we have found. So I think with that you found it very easy to understand what is proximate analysis. Now in continuation of the same, in the next video I'll be coming with the ultimate analysis and the comparison of both. Thank you everyone for liking it, and don't forget to subscribe the channel.